So, hello and welcome, everyone. It's a delight to have you here with us for this summer Tuesday Spotlight. And this is the final instalment of a mini series we've had within our Spotlight lectures on climate change and heritage adaptations, a follow-on series after a project funded by the British Academy. And we have been having some of these lectures to just explore the topic further within just Egypt. The original project was on North and East Africa more widely. And so we do have a dashboard on our website that I'll pop a link in the chat or the YouTube description where we have collated these events, but also other resources so you can find out more about the topic. So please do visit that as we are now closing this mini series with a brilliant lecture. But do visit that afterwards where you can find out even more. But let's get back to today's event. So what is the future for Amarna's mudbrick heritage? And I'm delighted to introduce our speaker for today, Dr. Anna Stevens, who is, of course, joining us from the Amarna Project office. She is a lecturer in archaeology at Monash University and directs the Amarna Project on behalf of the McDonald Institute for Archaeological Research, University of Cambridge. So thank you so much for joining us today, and we are all excited to hear your thoughts on the mudbrick heritage at Amarna. Over to you.
Thank you very much, Charlotte. Thanks to the AES for the opportunity to speak today, and thanks to you all as well for joining me. So, as Charlotte said, the question I'm posing today is, what is the future for Amarna's mudbrick heritage? And it's a question that I'm going to just start exploring from the perspective of climate change in the Nile Valley. Now, the Amarna Project has a very long history of working to help protect the archaeological remains at Amarna in partnership with the Ministry of Tourism and Antiquities, and in fact with the EES as well. One priority of the work that's been done has been to preserve and reconstruct some of the major monuments at the site, like the North Palace, which you can see in the photo in the top left here, also the small Aten Temple, the Great Aten Temple. And this is work which was led by our late director, Professor Barry Kemp, and which has brought great benefit to the site and to visitors. Within the last decade or so, we've also started to prioritise public engagement and community archaeology. And in 2020, we finalised a major site management plan, which was led by Dr. Gemma Tully. And you can read more about these initiatives on the Amarna Project website. It's only very recently, though, that we've started to consider how climate change might be integrated into our work programme, both in terms of our contributions to heritage management and also in our research more broadly. And what I'd like to do today then is to share with you some of the very preliminary steps we've been taking in recent months around this question of how to deal with mudbrick heritage in the face of climate change. So for anyone who needs a quick bit of background on Amarna itself, this of course is the site of the capital city that was established by King Akenatan in about 1350 BCE and occupied for only about 15 or 20 years. It has a really extensive excavation history with widespread excavations in the early 1900s, which then led into the current project, which started in 1977, established by Barry Kemp. And collectively, well over 1,000 buildings have been excavated, and the vast majority of those, whether houses, palaces, elements of temples, are all made of mud brick. And because of its short period of occupation and its extensive excavation history, and you can see some of the EES excavations in the early 1900s here, because of its short period of occupation and the extent to which it's been excavated, Amarna is the most intact, the most accessible, and one of the most extensively studied pharaonic cities that we have available. So on the one hand, Amarna is a really vibrant hub of research, but on the other, there's the reality that it's also a very fragile heritage site. This is the case for many of Egypt's ancient settlement sites. Now, the most pressing threats to settlement sites in the Nile Valley tend to be people-driven rather than environmental, so they're particularly vulnerable to damage from the encroachment of modern towns, fields, and cemeteries. There are, of course, also clear background environmental threats, like damage to ancient structures from exposure to wind and rain, and so on. So what you can see on this slide here, for example, on the left is a Google Earth image of Amarna with labels showing the ancient remains, mostly on the low desert there. And you can see how the modern fields and towns are starting to hem in the site. And the two photos on the right just show you what that actually looks like on the ground, where there are very few sort of protective barriers around the edge of the archaeological site, which is just sort of barely managing to hold back the fields and the modern settlement. In looking at these threats and in understanding these threats, we need to first of all acknowledge the role of archaeology in inadvertently helping to create them. So at Amarna, for example, excavators who were working in the early 1900s tended to leave the structures that they excavated uncovered. So instead of backfilling them like we would today, so when they were working here, for example, instead of recovering these structures with spoil from the excavations, they left them open and exposed. And of course, this has made them very vulnerable to damage from weathering and exposure. It's also the case that archaeological teams have tended to work at something of a distance from local communities, haven't really done enough to, for example, communicate back the results of fieldwork and share the stories of the heritage that is on the doorstep of these communities. Balancing the needs of local communities with the needs of the heritage site is a major challenge, and it's one that rests largely with the very dedicated staff of the Egyptian Ministry of Tourism and Antiquities. And at the Amarna Project, we're doing our best to help where we can. So how do we bring in climate change, the question of heritage management at a site like Amarna? First, of course, we need to recognise that climate-related threats to sites in the Nile Valley won't be as acute as in regions like the Delta, which are facing rising sea levels and where large-scale loss of archaeological sites is predicted. Nonetheless, from the data that we do have available, the expectation for the Nile Valley is for more extreme temperatures, irregular rainfall, increasing soil salinity, the potential for increased flash floods, and more. So what we can anticipate for the Nile Valley is that climate change is going to start layering weather that's more extreme and less predictable onto heritage that is already vulnerable. And of course, the attendant social impacts of these environmental changes are also potentially wide-reaching and could also impact heritage in secondary ways. So, for example, through changes in farming practices or economic instability that might lead to the looting of sites and so on. Now, even if we stand at a distance from the archaeological site, it's easy to anticipate some of the ways in which more extreme and fluctuating weather is going to start affecting mud brick buildings, whether they've been exposed through excavations or are still buried below ground. So clearly, harsher winds, for example, are going to pick up abrasive sands and are going to erode brick surfaces. The fluctuations between extreme temperatures and also between drier and wetter conditions also has the potential to cause slow but steady damage to mud brick. What happens to mud brick is that as it absorbs moisture and then dries out and goes through this cycle of wetting and drying, the mud brick gradually turns to dust and it is then blown away. And we can see that this is already a significant problem at Amarna. You can see how it's affecting a number of the monuments at the site. What we've also seen on site over the past decade or so is that as the air quality in the region has become poorer, it tends to trap very heavy fogs over the site, and these have enough moisture in them to also cause the brick surfaces to degrade in this way. And then there's the obvious threat as well of flash flooding, which is caused when heavy rainfalls accumulate on the high desert and wash down through the valleys, heading across to the Nile Valley and with the potential to cause damage to anything that lies in their way. And perhaps the best illustration that we have had to date of the really destructive power of flash floods on heritage sites like Amarna occurred in 1990 when the royal tomb at Amarna, the burial chamber of the royal tomb, was almost entirely filled up with water from a flash flood that came across the top of the high desert. And so in the left photo here, we can see an ES archive photo that shows the entrance to the royal tomb in the 1930s, and a more recent set of photographs on the right that show flood protection barriers that have since been put into place to prevent another flash flood causing damage to the tomb. So you can see the shelter that now exists over the entrance to the tomb, and a wastewater drainage channel that runs down the entire length of the royal wadi. So while we can stand back and predict these increasing threats, we can also directly engage with the site to try and better understand them. And as it happens at the moment, at Amarna, we're running a 3-year pilot project, which is funded by the American Research Center in Egypt. It's called Akenatan City, Protecting Amarna's Urban Heritage. And it is looking specifically at the question of what can be done to protect Amarna's mud brick houses. Now, of the buildings that were excavated 100 years ago, the vast majority of those were mud brick houses. So there's around 1,000 of these structures have been uncovered at the site, and at least as many remain buried below ground. What we're doing as part of this project is, first of all, re-clearing and re-recording a sample of houses that were excavated in the early 1900s to try and improve the records that we have from these buildings. And you can see some of that work going on in the photos on the right there. We're also undertaking a very large-scale photogometric survey of the main city, which is the largest of the ancient suburbs. We're running a program of community archaeology and public engagement. We're building a set of protective boundary walls around particularly vulnerable areas of the housing suburbs. And we're also undertaking conservation at the villa of the Vizier Nacht. So the project is designed in part to directly protect housing areas through the conservation and the wall building program, but it's also intended to promote more positive engagements with these buildings from both the public and the academic communities, with the idea that the more we can demonstrate the varied values of these mud brick structures, the greater chance there is that they're going to be protected going forward. Now, when we designed this project, we weren't necessarily thinking about climate change, but now that this project is getting us out into the field, directly uncovering, observing, and recording this huge sample of mud brick buildings, we're starting to consider how we might bring a climate perspective into the work. So what we have at Amarna is an unusually large data set of mud brick buildings of various scales, compositions, and locations. We also have an extensive archive of excavation records that go back over 100 years and tell us about the condition of the houses at that time, the time they were excavated. And we have developing programs of both local community engagement and of digital archaeology. So we're just now, over the last few months really, beginning to sort of pull this all together in a 2-part methodology that's first trying to assess how Amarna's mud brick buildings have been affected by environmental processes across the past 100 years through on-site survey, archival research, and local community knowledge. We should be able to compare what we see today with the records of these houses made by excavators 100 years ago and better understand recent rates of environmental loss and the factors that influence this. And the second part of our methodology then is more forward-facing, and it involves thinking about how digital modelling might offer a tool for both tracking and predicting ongoing climate threats. So for the rest of today's talk, I just wanted to walk you through a few examples of what we've been observing and doing in the field and how this methodology might take shape going forward. So on the one hand, when you walk around the city of Amarna, if you ever get the chance to do that, what can strike you first is really the resilience of mud brick. There are some incredibly well-preserved houses that stand out in the desert. You're looking at one of those here. This is the house of a priest called Pawas. It lies on the eastern fringe of the main city. This is the housing suburb I mentioned earlier. It's the largest area of houses that we have at Amarna. Pawas' house is out around in here. It was first excavated in 1911, and you can see that it still survives today as an incredibly impressive monument. Once you do start to walk closer and take a closer look at these large houses, though, Pawas and other examples, the perspective starts to change. Here we can start to really see the processes of decay at play. Some of the damage that we're looking at here is caused by animals burrowing under the walls and wasps building nests in the mud brick. But you can also see here the results of sort of slower scale environmental impacts, where we can see the walls starting to crack, bricks are falling out of the walls and slowly crumbling to dust. And I just want to offer a reminder here that there's really nothing that local heritage managers can do about a problem of this scale. There are hundreds of these houses in this condition, all excavated a century ago, and it's really unfeasible to think of conserving or backfilling all of them. So it's a really major challenge. If we zoom out again and have a sort of wider look across an area of the main city, again, we might notice a lot of standing houses and think that things don't look too bad at first glance. We're looking here at an area that was, again, extensively excavated in the early 1900s, and then these buildings were all left uncovered and exposed. What we have to look at here, though, is the areas in between the standing houses. So here we have some fairly nicely preserved mud brick houses in here. We need to consider these areas all around. Now, 100 years ago, these large and mid-sized houses would have been surrounded by groups of smaller mud brick houses and peripheral structures. And now these smaller houses are only represented by these low ridges that you can see peering out of the desert sand. We have actually done a little bit of clearance in an area of this kind just to test what lies below the surface. You can see the area that we chose to excavate here, where you can just make out sort of the ghosts of thin walls poking out through the desert here. And this is what it looks like after excavation, where you can see, in this case, we don't have standing architecture anymore. We really just have walls that are preserved to 1 or 2 courses maximum. So it's pretty clear that these smaller houses that were built with thinner mud brick walls appear to have suffered the most from 100 years of exposure to the elements. I'll return to the implications of this a little bit later. So what we're trying to do now is to go back through the early excavation records and look for data that was kept on, for example, wall heights at this time, so that we can relocate these houses and work out how much brick volume has since been lost to weathering over the past 100 years. We really need to start generating sort of firm data on rates of loss over a known period, so that we have a baseline that's going to help us understand future change. Now, another of the houses that we've re-cleared recently as part of the survey is the villa of one of the viziers. I mentioned him earlier. This was a man called Nakts. And by chance, Nakts' villa provided us with a really important glimpse of another environmental hazard at the site, and this is flash flooding. Now, Nakts' house was first excavated by the EES in 1922, and it was celebrated at this time as an outstanding example of a grand Amarna villa. So in the top left, you can see an excavation photograph that the EES excavators took in 1922, and you can get just a little glimpse there of how well preserved the house was, and also how fancy it was. As you can imagine, it's one of the largest houses that's ever been excavated at Amarna. It dwarfs those that are closest to it in size. Of course, this is fitting for a vizier. It has a very elaborate layout and a very elaborate set of internal fittings. You can get some sense of that in the ground plan in the top right. There's over 30 rooms just at ground floor level. Now, the house lies on the outskirts of the town of Al-Hajkandil, as you can see in the photograph in the bottom, taken in 2023. And over the last century, the house has suffered very badly from human activity connected with the growth of the township. So while the house walls once stood to well over a metre, as you can see in the photo on the top left, today they're preserved to just a maximum of a couple of courses. And here you can see the house during reclearance just in May this year, in fact. Now, it was already clear before we started re-clearing the house that a lot of the height of the walls had gone. And we assumed that this was probably a result of traffic over the site and maybe people removing the bricks for reuse. But as we did clear the house, we encountered a layer of lightly coloured mud. And you can see that crackled mud in the photographs here, which covered almost all of the floors of the house. It was a really thick, very distinctive deposit. Now, this is mud that's been deposited by a huge flash flood that has evidently swept through the house sometime after it was excavated by the EES. In some areas, we could even see that the floodwaters had sort of undermined the bottom of the brick walls. And it was the floodwaters that had then caused the wall to actually collapse. So this must have occurred quite dramatically, as maybe, you know, 1.5 meters of brick wall fell down in one go when the flood swept through. So what Nakts House shows us here and warns us about really is a more discrete and a more acute threat, a sort of sudden weather event that has the potential to cause really rapid and quite catastrophic damage. Now, local oral history recounts a major flash flood that swept through the southern part of Amarna in the 1960s, which is probably the event that damaged Nakts House, and presumably it must have damaged many of the other ancient houses in its vicinity. It also caused very considerable damage to modern houses and farmland. Flash floods of this kind seem to be occurring around Amarna in recent decades on a cycle of around a decade or two. Now, not all of them necessarily cause damage to the archaeological site, but some clearly do. We've seen that in the 1990 flood at the Royal Tomb, and now we have another clear example of how it's affected the housing areas as well. So there's a major question here that looms of how these cycles are going to be affected under changing climatic conditions. It's not a question that we as archaeologists are best placed to answer, but we certainly need to engage with this problem. So a next step then for this housing survey is, on the one hand, to quantify recent environmental damage, as I've also mentioned, but also to think about it in terms of such factors as the location of the buildings that have been most affected, their scale, and even perhaps the composition of mud brick that's used, to consider the different impacts of these variables. The goal, of course, is to ask, you know, can we start to predict which areas or buildings will be most vulnerable to more extreme weather in the future? Now, I mentioned our emerging methodology has two parts, and the second part involves a very ambitious photogrammetric survey undertaken by Paul Doherty, and you can see Paul in the photo here. And he is surveying the largest of Amarna's ancient housing areas, the main city. Now, initially, we were thinking that the photogrammetric capture would serve mostly as a supplement to the maps and the aerial photographs that already exist for the site, to provide a further resource for researchers, but also to serve as a sort of digital surrogate of Amarna. But again, as the work is going on, we've started to realize how the survey itself might also serve as quite a powerful multi-purpose tool for documenting, monitoring, and modeling climate-driven threats. So Paul's survey is capturing thousands of overlapping georeferenced images to produce accurate 3D point clouds and textured meshes that record surfaces of structures and also of the wider landscapes that they sit in really incredible detail. In effect, what he's doing is creating a comprehensive baseline of the condition of the site now, against which all future changes can be measured. It's the kind of detail that could never be gained through planning or standard photography. So what we could do is repeat this kind of survey at a chosen interval, perhaps annually, perhaps immediately before and after major weather events, and then run direct comparisons to arrive at a very precise calculation of how much material has been lost. In theory, it'd be possible to detect very small-scale subsidence in foundations as well, or to map the progress of wall erosion, deformation, or collapse. We might be able to see subtle ground and wall movements that are caused by rising damp and salt crystallization. So in a way, this element of the methodology mirrors what we might achieve through the archaeological reclearance to look at changes across the past 100 years, but now we're looking forward. Our baseline is today, and we monitor the condition of the site going forward using the photogrammetric models that we're generating, and we monitor it on a much more sort of finely tuned scale. Now, at the moment, Paul's survey is being undertaken on a massive scale. You can see in the image there the area that he surveyed just in the first season of work that he undertook in 2023. It would be really unfeasible to think of recapturing large landscapes of this nature as we're doing now, but we might think of selecting some case sites, particularly buildings, and sort of running repeat captures of these over time. And Paul is already, of course, starting to to generate captures, not just of buildings in their landscape, but very highly detailed captures and photogrammetric models of individual buildings. And you can see some examples here. Another potential use of the photogrammetric model is to generate a digital elevation model of the Wadi channels, desert plateau and terraced landscape of Amarna, and use hydrological modeling to predict flood pathways, water depths and velocities. And this might help us, of course, identify the lowest points and fastest flow corridors that pose greatest risk to mud brick buildings. And it'd help us identify buildings at greatest risk and potentially where interventions like diversion channels might be best placed. Finally, the virtual 3D environment that Paul's creating also supports conservation planning, stakeholder engagement, and other activities. So engineers, for example, use 3D environments to simulate what-if scenarios, such as visualizing how a proposed flood barrier will redirect water runoff. They produce aerial fly-through animations to make the case for specific interventions more compelling to authorities or communities or funders. So by deploying this kind of systematic, repeatable photogrammetric survey, we should be able to start transforming qualitative observations of decay into sounder quantitative data. And through this, in theory, we'd then be able to really empower sort of evidence-based decision-making for flood control, groundwater management, and desalination treatments. So just to close then with a few initial thoughts in answer to the question of what the future is for Amarna's mud brick heritage, we can expect that climate extremes are going to exacerbate a wide range of existing vulnerabilities and speed up rates of heritage loss. Difficult decisions are going to have to be made about where interventions and conservation work should be focused for longer-term impact. But we should also be proactive in making those decisions rather than waiting for a hand to be forced down the line. We need to be working with this challenge now. And Amarna should be one site where we can really start to generate data that gives us a more nuanced understanding of the threats, the rates of loss, and wider impacts of climate change on Nile Valley heritage. Even this very preliminary work, and it is obviously we're just at the beginning, but even the work that we're starting to do is helping us to see potential changes in the profile of weather-related threats. We're wondering, for example, whether flash flooding, rather than this slower background weathering away of mud brick, whether flash flooding is going to become more prominent than it has been to date. We can start to see, to imagine that there might be sort of changes in rates of loss, and perhaps we're going to start to see more episodes of more acute damage, again through floods or perhaps through events like looting, large-scale encroachment, if economic pressures on local communities increase. And we're also starting to become a little bit more aware of what will be lost in more social terms, not just material terms. As just one example, it's already clear from what I've shown earlier that the smaller houses built with walls that are just 1 brick thick are among the most vulnerable to environmental decay. And these are the houses that represent Egypt's non-elite, whose experiences are already underrepresented in Egyptological scholarship. So here we risk losing even more of the primary evidence that represents their lives. So we need to build up more data, and we need to think about what we want this data to do. So just to close, I'll brainstorm a few of the wide range of questions that remain. We have to ask, what's the future for conservation projects that use mud brick to restore monuments? Is it worth continuing to cap monuments with mud brick given the vulnerability of this material? Can we learn more about the resilience of different ancient bricks and work this technology into conservation projects? Are we going to have to look more towards water management projects like drainage channels to deal with flash floods? How is climate change going to affect local communities in terms of subsistence, farming, well-being, and what are the side effects for heritage? What more can we learn generally about traditional management practices and understandings of climate cycles? What can we learn from the ancient houses about how the ancient Egyptians themselves dealt with environmental challenges? And who among the community was most vulnerable to these? And where does archaeological research sit among this? How can heritage management and Egyptology become better aligned going forward? That's it from me today. I just wanted to close with a couple of thank yous. First of all, to Paul Dockery, Kate Spence, and Gemma Tully for their input into the work that I've been presenting today. I wanted to thank the Egyptian Ministry of Tourism and Antiquities for their support of our work, and of course the Amarna team and the communities who are living on and around Amarna. So thank you very much.
Thank you so much, Dr. Anna Stevens, for such an interesting presentation. I think, yeah, you touched upon such significant factors that all archaeologists working in Egypt should be really considering right now, and thoroughly explained how important it is for archaeologists to get involved in this, I guess, this fight against climate-driven threats. So yeah, I think it's such an important topic. And as you mentioned, of course, it's very preliminary, but I think it's a great way for everyone to start thinking more holistically. And I loved how you ended there about yeah, how to align heritage management and Egyptology more closely. It's something to really consider in future. Thank you so much. And I did mention earlier that, of course, this is our last Spotlight lecture on this topic. However, it's not the last medium we will be looking into. We will be releasing a very special online supplement of Egyptian archaeology very soon for EES members. And you can read even more about this project from Anna Stevens and her colleagues, as well as other projects that contributed to our conference on climate change and heritage adaptation in September last year. So if you are a member, look forward to receiving an email about that soon. If you're not yet a member, I'll put some links in the chat for you to become a member, and then you'll get access to that so you can read even more about this work. So, and thank you again for all of your contributions to this wider British Academy funded project. A massive thank you to Dr. Anna Stevens. Thank you for joining us today and presenting such an interesting and I think novel topic for Egyptology. I think it's something that hopefully will grow much more over the next few years, I'll say. And of course, we have this is part of that wider climate change and heritage adaptation project. That there's the dashboard on the EES website, so please do go there and you can find out even more information, or wait for this summer's online Egyptian archaeology supplement, which will be focused completely on climate change and heritage adaptation, with an article by Anna Stevens and her colleagues to go into it even further, as well as other projects exploring the topic. So yes, thank you all so much, and thank you for all of your lovely messages saying how interesting the talk was. It was a delight to have you, and really interesting to see these preliminary studies on the methodology you're using at Amarna. So thank you so much.
Thank you.
And yeah, hopefully we'll see you all soon at our next Spotlight, which will be on a completely different topic, but hopefully we'll see you there anyway. So thank you all. Thank you, Anna, and hopefully see you all soon. Okay, bye.